In this lesson, we're going to talk about rational exponents and property of exponents. So here's an exponent or a power. We consider the big number here the base of the number, and m is the exponent or the power. If I see something like this, the 3 is the base, and the 5 is the power, or the exponent. And then all this means is, this is how many times we want to multiply the base by itself. So in this case, we're going to multiply 3 times itself 5 times. 5. That's what 3 to the 5th means. It means 3 times 3, 5 times. And then you can multiply it all together, and you get 243. Same thing works here. If I was doing this one, my base is x, that's the base, and this is my exponent, or power. So this means multiply x by itself 4 times. Now that we know the basis, let's move on to a few of the properties. The first property is a zero power property. That's anything to the power of 0 is equal to 1, except 0. And that is because I always like to think of anything to the 0 power as a number over itself. That makes it 1. So like if I give you 6 to the 0, that's just 1. Oh, over here, x to the 0, that's just 1. Anything to the 0 power except for 0, that's undefined. For the same idea, you can't divide by 0. 0 to 0 be 0 over 0, and you can't divide by 0. And by everything else, it's just 1. So that's the 0 power property. Anything to 0 power except for 0 is 1. The product of powers. To multiply powers with the same base, you add the exponents. Coefficients are multiplied together. All they're saying is like here, I'm going to multiply 2 to the third times 2 to the second times 2 to the first. All we have to do is add the exponents. This rule is x to the m times x to the n is equal to x to the m plus n. So all we do is add all these exponents together. 3 plus 2 plus 1. That gives me 2 to the 6. And if you look at this, that's the same thing as saying 2 times 2 times 2. 2 times 2 and 2. And we have 6 2's. 2 to the 6. That's the shortcut of doing this. If you're multiplying two things and they have the same base, you just add the exponent. 2 plus 5 is x to the 7. Down here, same idea. We're going to keep the numbers and the exponents separate. The numbers we're multiply together. The numbers 3 times 2 and -1. Almost forgot the -1. That is -6. And then we got to do the variables. We have x5. If there's not a power, it's a 1. 5 plus 1 is x to the 6. You're telling yourself, how many variables do I have here? I have 5 plus another 1. I have 6 total variables. And then the numbers you just multiply. The same thing will happen here. We're going to multiply all the numbers together. So I get 4 times -3 times -2. That's -12 times -2 is a positive 24. And then for the variables, you just do each one separately. X squared, we got x. We have a total of 3 x's. And then my y's, I have 1 plus 5 plus 4. Right, that's the way we're going to do it. 1 plus 5 plus 4. I have 10 y's total. Next, the power of a product property. All this is saying in this case is if you have two things in parentheses to a power, oops, let's put a random power. That goes to both of them. That exponent goes to both things in the parentheses. That's what's going on here. So like the example here, this is a common example people get wrong all the time. 2x to the third. I get so many people give me 2x to the third as the answer. No, that 3 goes to both of them. It's 2 to the third, x to the third. 2 to the third, 2 times 2 times 2. That'll give me 8, x to the third. Over here, same concept. That 4 doesn't go to everything. 3 to the 4th, x to the 4th, y to the 4th. That's 3 times 3 times 3 times 3. 9 times 9. 21, x to the 4th, y. Over here, same concept. That 2 is going to go to every single one. That's -3 squared. In parentheses, we'll talk about. Then we have x squared, y squared, z squared. Remember that -3 is going to power of 2. I put in parentheses because when you square a negative, when you square anything, it should make it positive. Because you're doing -3 times -3. That's a positive 9. Two negatives make a positive. Anytime you do an even power, it should be positive. And there's my answer. The power of a power property. That's when you have a power and you bring it to a power. AB to the power of k. All you do is multiply this times that. So it'd be a, b, k, like that. You multiply the two exponents. When we multiply and they have the same base, and in this case, we would add them. You just add all the tops. But you make that a power to a power, like these, and then we're going to multiply them. And let's show you why. This first one here, the rule says, all we're going to do is multiply these top two. 3 to the 2 times 3, which is 3 to the 6. If you want to know why that happens, it's the same thing as 3 squared, and there's 3 of them. That's what it's saying. 3 squared to the third power. We're going to multiply 3 squared 3 times. And all we have to do here is add the tops, and you get 3 to the 6. So it's the same concept. You can either add x to the 4th 3 times, and then add them all up, and you get x to the 12th. Or you can just multiply. That's why we multiply. So we don't have to add up many things together. So that's the basic rule here. In this case, same idea that 2 is going to go to every single one. -5 squared, x squared squared, y cubed squared, z squared. Z doesn't have like a power itself, so it's like that. -5 squared is 25. X squared squared is x to the 4th. Y cubed squared, so when we multiply those two, we get y to the 6th, and then we get z squared. That's a power to a power. The power to power you multiply. A negative power, one of my favorite ones. All that says, like what it says there, is you have a negative power that flips. It flips the base. You get 1 over a to the n, like that. It works even if you have it on the bottom. If you have 1 over a to the n, or I should put a to the negative n, that will flip to the top. Right? The negative power flips it, flips the base upside down. You might wonder why that happens. Let's look at 5 cubed. That is 125. And if I want to divide that by 5, on this side you get 5 squared, which is 25. And you divide by 5 again, and we'll get 5 to the first, which is 5. You can see when you divide by 5, all you're doing is like losing the power on the exponent. So now we're just multiplying. Then multiplying 5 by itself 3 times, we're multiplying by itself 2 times. And then we're multiplying by itself 1 time. And then we get 5 to the 0. Well, divide by 5. That is just 1. 5 divided by 5 is 1. 18 to the 0 power is 1. And we divide by 5 one more time. You get 1 over 5. Follow the pattern here. Every time we divide by 5, we're subtracting 1. 5 to the negative 1. And you keep on going. 5 to the negative 2 would be divide by 5 again. 1 over 25. Or 1 over 5 squared. That's it. There's 1 over 5 squared. So you can see how it works. So negative power just flips it. That's all it does. Flips the base. So if I was doing this one here, that's a negative power. So I'm going to flip the base. That becomes 1 over 2 to the third. Sitting over here, it just flips the base. 1 over negative x to the fourth. It is flipped already. It's already a fraction. Let's distribute this first. We get 1 to negative 2 and 3 to negative 2. That's going to flip up. That's going to flip down. And now you get 3 squared over 1 squared, which is the same thing as just 3 squared, which is the same thing as 9. So same thing we've done here. Flip that up, flip that down. 3 squared over 2 to the fourth. Or if I want the actual numbers, 9 over 16. All right, that's just 2 times 2 times 2 times 2, which is 8 times 2, which is 16. What I do want to mention is that when you have negative exponents, generally, you don't want to end with negative exponents. They need to become positive. If you see, I didn't just leave it 2 to negative 3 or 1/3 to negative 2. You have to flip it. You want to become positive exponents. You don't ever want to end with negative exponents. You always want to end with positive exponents. Okay, let's move on to the next one. Quotient of powers property. This goes hand in hand with the product power property, right? Where we had two things with the same base and we multiply them. Then we just add the powers or the exponents. If you're dividing two things with the same base, that we subtract them. Now the way we subtract it, top minus bottom. Very important. The top one minus the bottom one. The numerator minus the denominator. So in this case, let's say we have this one. Let's show what's going on for a second. We have 3 5s on top. 1, 2, 3, 4, 5. All being multiplied. All over 3 2s on the bottom. If you look at here, these 3's cancel out and these 3's cancel out. So you end up with 3 to the third. An easier way to do that though, so we don't have to rewrite it every single time, is just going. We can do the top one minus the bottom one. 3 to the fifth minus 2. 3 to the power of 5 minus the power of 2. And you get 3 to the third. Like that. Which is, by the way, 27. 3 times 3 times 3. Anyway, the next one, x over x squared. We're just going to go x7 minus 2, which is x to the fifth. Just like we put 7 x's up here, and then 2 x's down here, and then cancel out 2 of them. This next one, what happens when there's numbers? You just do the numbers separately. 2 over 6, we can reduce that. 2 over 6, if we divide them both by 2, then we get 1 over 3. That's going to be my answer. 1 over 3, now we got to do the variables. We're just going to do each one separately. We have x to the third over x. That's going to be 3 minus 1, which is x squared on top. And then we're going to have y squared, y to the 6. That is y2 minus 6, which is y to the negative 4. We'll talk about that in a second. Now, if you remember from the thing we just talked about, you cannot have negative exponents. We don't want those in our final answer. What we're going to do here is we're going to flip this y to the bottom. So I'm going to get x squared, 3, y to the fourth. And that's the quotient power property. If they have the same base, you just subtract them, top minus bottom. If you get a negative at the end, you do have to flip it to the bottom. And then the power of quotient property. So this one I actually used, didn't realize I haven't explained it already. If you have two things and they're also power, that could distribute to both of them. It goes a to the k over b to the k. So I was going to do the first one here. That 3 goes to both of them. I get 2 to the third, 5 to the third. The third is 125. Over here, that negative goes to either one. Goes to the top, goes to bottom, doesn't matter. Most people put it on top. Negative x to the fourth, y to the fourth. Anytime you have an even power, it makes it positive because you're basically doing negative x times negative x times negative x times negative x. These two multiply to get you x squared. Positive because two negatives make a positive. These two get multiply to get you x squared. You get x to the fourth. Anytime you have an even power, you get a positive number. Something like that. And then here, same concept, that the reason to go to every single one, even on the bottom, it's negative 2 to the third, x squared to the third, y cubed, 3 to the third, and z to the third. Notice I went to everything. I didn't just put it to the z. I didn't just put it to the 3. It goes to every single component here. So you get something like this. Now, this is an odd power. It will stay negative. Negative 2 to the third is negative 8. X squared to the third. Remember, in this case, power to power, you multiply them. X to the 6, y to the third. 3 cubed is 3 times 3, which is 9, times 3, which is 27. And then z to the third. And that would be my answer to that one. And then last thing, rational exponents. If you have a to the 1 over n, the top is the power, the bottom is the root. You could rewrite this as the square root of a to the power of 1, and then the root is right here. So that's what it means. If you see like a fraction exponent, all it means is the bottom is the root, the square root of something, or the cube root of something. If I see this first one here, 36, remember the way it works, that's the power, and then this is the root. If I'm gonna rewrite it, power never changes. 36 to the first, and the root is 2. Now, if you've never seen square root before, square root is like the opposite of a power. It's saying what times itself 2 times equals 36. What times itself 2 times is equal to 36. And that number in this case is 6. 6 times 6 equals 36. 6 squared equals 36 is the idea. This answer is just 6. Same thing with the next one. That's the root. That's the one that changes. The power never moves. This is the power. So it's going to be 100. I do square root, power of 1. This would be 2. You're basically asking yourself, what squared equals 100 is the idea here. The number squared equals 100? 10. So the answer to this guy is 10. The next one, that's the root, and that's the power. In this case, that's going to be 8 to the cube root. The cube root of 8. Power is 1. You don't need to write it. Again, this is asking you what to the third power equals 8. What times itself so 3 times equals 8. And that number will be 2. So that's my answer. This is 2. Okay, that's the lesson.